Hi everyone. So for the Precambrian Paleozoic project presentation, Leo and I will be covering the Sassenach Formation. As seen here in the title page, we outlined it in red. This image was taken and a part of Mackenzie 1969's paper and was taken near the headwaters of Cardinal River. But we hope you enjoy our presentation.
The Sassenach Formation was first defined in 1962 by geologists McLaurin and Mountjoy. It was first defined in Jasper National Park and named after Mount Sassenach, the closest mountain to the type locality. Mount Sassenach's location can be seen on Figure 1. The Sassenach Formation is early Fenian in age. This is found in the late Devonian Paleozoic and can be seen outlined in the red box on Figure 2, the GSA geologic timescale. The Sassenach Formation was formed from a basin infilling during a global sea level fall in the late Devonian. Sediment sources for the clastic component of the Sassenach Formation are believed to be 1. An eastern source from the Canadian Shield, 2. A western Laurentian margin source, and 3. Sediment recycling from Franklinian. The type locality for the Sassenach Formation can be seen at the yellow dropped pin on Figure 4. Note that the Jasper townsite is located at the bottom of the map, approximately 34 kilometers south of the type locality. The Sassenach Formation is a small, locally confined unit spanning, as you saw, from northern Jasper National Park to the North Saskatchewan River. It is also possibly located in the Crow's Nest Pass area, as it shows remarkable similarity with the Graminia and Kalmar formations. However, this has not been confirmed. Figure 5 shows you the location of the Sassenach Formation in the Rocky Mountains of western Alberta, beneath the Palliser Formation and above the Mount Hawk Formation. The thickness of the Sassenach Formation varies in the south, where it pinches out, to the northwest, where it is up to 224 meters thick. As a basin-filling unit, it only fully developed away from the carbonate buildup margins of the Fairholme Group, where it overlies the Mount Hawk Formation. Figure 6 are snapshots taken from the Alberta Table of Formations, where A, the overall view of the geology surrounding the Sassenach with timescale to the left, and B, it shows a close-up of the Sassenach Formation and surrounding formations. The Sassenach Formation is outlined in red boxes in both. Basinal contacts of the Sassenach Formation include a conformable contact above the late Frasnian Devonian clastic facies Mount Hawk Formation of the Fairholme Group in the northern and southern foothills of Alberta. The Sassenach Formation is also located unconformably on top of the late Frasnian Devonian Reef Facies South Esk Formation in the northern and southern mountain region and Alexo Formation in the central and southern foothills of Alberta. The Sassenach Formation conformably grades into the Middle Fenian Devonian limestones of the Moro member of the Palliser Formation above. Figure 9 shows labeled formations along the Peachey Reef Front, South Lost Creek, Flathead Range, Alberta, looking west. The formations are labeled, and you can clearly see the Sassenach located below the Palliser and above the Arcs formations. The Sassenach Formation is laterally equivalent to the upper member of the Alexo Formation type section at the North Saskatchewan River Gap. As previously mentioned, the Sassenach Formation is also homotaxial, meaning similar to, the Kalmar and Graminia formations of the central Alberta subsurface and the Crowfoot Formation of southeastern Alberta. In Figure 10, A is a picture of the base of the Sassenach Formation on the Moro Peak Traverse, as in an outcrop of the Sassenach Formation, and B is core from the Graminia Formation.
Now for lithology. So a general overview of the Sassenach Formation is that it is siliciclastic and carbonate strata But to be more detailed, McLaren and Mountjoy divide the Sassenach Formation informally into two members, the first being the Upper Sandy member. This member is medium to coarse-grained sandy quartzose limestone containing calcareous sandstone that takes up approximately the middle third of the member. You can see that in figure 11 on the left-hand side. Few fossils are noted here, and generally it is resistant to weathering. Secondly, the lower silty mudstone member. This member has a variable amount of dolomite and is calcareous. Its color is dark gray to green-gray, and it is a quartzose silty mudstone that weathers to a distinct yellow or gray-orange color. Lastly, the carbonate content increases upwards, where bedding is medium to thick, silty, and argillaceous limestone. Now, we'll speak to figure 11. So this is simply just a strat column of the lithologies found in the Sassenach Formation. It is broken up into the upper member and the lower member, so it makes it a little bit more obvious, as well as the upper contact with the Palliser Formation is visible, as well as the lower contact with Mount Hawk Formation. And this location is at Morrow Peak. Paleontology. McLaren and Mountjoy suggest a difference in fauna between the upper and lower members of the Sassenach Formation. The upper members only fossiliferous in specific sections, but within these sections, the fossils that may be found are bryozoan and crinoid fragments, as well as rhynchonelloids. On the right-hand side in figure 12, you can see rhynchonelloid brachiopods from the Upper Devonian, and specifically the Flaminian. These are some examples of the fossils you may see in the Sassenach Formation within the upper member. Now the lower member, you may see oncoids, as well as it is extremely rich in brachiopod fauna, such as Schizoporia and Productella and all the others listed below. So now the next few slides will just kind of outline some of the specifics of what you may see within the lower member. So here we've got oncoids. Figure 13, so A through D, is just an oncoid photomicrograph showing the internal structure. And then figure 14 is an oncoid rudstone of the Flaminian. Right, so now we will move on to the brachiopods. So here are just simply examples of Devonian brachiopods. Figure 15 outlines Schizoporia, which is found within the lower member, as we noted 2 slides ago. So then you can see that in the top figure 15, A through J, and then in figure 16, we've got ventral and dorsal view of Productella that may have been present in the Sassenach Formation at this time. Facies interpretations. So the Sassenach Formation can be defined as a basinal infill sequence where deposition occurred during a period of regression. Price suggests that there's approximately 300 to 500 feet of relief between the top of the reef margin complex and the deepest areas of the basin. The lower member deposition follows the upper Fairholme group and continued without interruption during the regression. And the reef margin complex is thought to have been destroyed, and the upper member is deposited over both the reef complex and the basin. Now on the right-hand side in figure 17 shows the upper and lower Sassenach members at the Mount Meta location, where the hard red line breaks up the upper and the lower members, and the thinner red lines just keep the boundaries between, like on either end. Resources. Unfortunately, there's very limited information on the available resources of the Sassenach Formation. But what is necessarily interesting is that the oil and gas potential in the surrounding formations. So we will speak to those. The Fairholme Group, which is overlain by the Sassenach or Alexo Formation, is a hotspot in regards to the prolific oil and gas reservoirs in the Flathead area, Beaver Hill Lake, Leduc, and Nisku Reefs of Alberta Plains and the Foreland Belt. Additionally, the Palliser Formation, which overlies the Sassenach Formation and Alexo Formation, is a prime hydrocarbon reservoir for the Foreland Belt, and 3 wells were completed here. On the right-hand side in Figure 18, these are 2 core samples from the Leduc field showing very large vugs. Additional information, conodonts. Conodonts in the fossil record are identified as tooth-like fossils that are found as constituents in poorly cemented sandstone and limestone. They are of particular interest to the scientific community as they are kind of a mystery, I believe, because they're scattered between many differing depositional environments, which leads scientists to believe that they are nectonic vertebrates and from phylum Chordata. Okay, so this slide is just simply to show that the conodont zones that the Sassenach Formation fall under is the Crepida as well as the Triangularis. Alright, and the summary. So we made this summary slide just as a kind of general wrap-up and kind of overview of what we've discussed in the PowerPoint presentation. We hope you enjoyed, and thanks for watching.